Hello and welcome to INE's CCIS Service Provider version 5 Learning Path. Today in this course we would talk about Nfvi, which is Network Function Virtualization Infrastructure. So the first thing before we understand network function virtualization, we need to understand the virtualization function. So let's look at an overview of virtualization functions. Now, a network function is basically a function that is performed by a physical appliance like a router, switch, firewall, load balancer, IDS, or a WAN optimizer. So anything which is done by a physical device is basically a network function. Most vendors have a proprietary solution in which hardware and software are tightly coupled together. Cisco is a good example of that. They sell routers and switches as appliances. You need the hardware and the software. You cannot run the Cisco iOS without the hardware, and you cannot run anything else besides Cisco iOS on these routers or switches. So basically, you need both. You need the hardware and you need the specific Cisco-specific platform or software to run on that hardware. Now that becomes a problem because you don't want to be stuck with one device or one vendor. You want to decouple them. Virtualization is an option. Nowadays we have virtual devices, which Cisco also has virtual devices that you can deploy. So virtual solution becomes more scalable. Now a VNF, which is a virtual network function, is basically a virtual appliance which was originally a hardware. For example, a router. A router is originally supposed to be an appliance. But now what's happened is that with me configuring or me deploying VNF, which is virtual network function, we are taking that hardware appliance, removing that part and deploying it as a virtual appliance. So virtualization is a big aspect in today's networking environment. So VNF provides a well-defined network functions such as routing, intrusion detection, domain name servers like DNS or caching or NAT, or even other network functions, for example, running routing protocols. While these network functions require a tight integration between network software and hardware in the past, the introduction of VNF has created or helped in decoupling the software and the underlying infrastructure. If you remember earlier, we used to basically have physical routers running iOS platform on that physical appliance. But now I don't need that physical appliance. What I have done with VNF is we have removed the appliance and we are now deploying the virtual image or the software platform on a different hardware, which could be maybe an EXXI host or a server or even a Red Hat KVM. I could deploy that on any hypervisor. So taking the hardware and the software, moving them away from each other and still having the same functionality. So VNF is basically a virtual solution of the same device which was earlier a hardware appliance and now deploying that on a non-Cisco or a non-vendor specific platform. Now, here are some examples of Cisco VNFs. So the meaning of VNF, when you think about VNF, you should always think about a virtual appliance. So it is basically a virtual appliance, which was originally a hardware. So vEdge Cloud is basically a virtual appliance or is an example of VNF. We have CSR 1000V, which is also an example of VNF. ISRV, we have ASAV, which is a firewall, which was earlier originally a hardware appliance, and now we can deploy a virtual firewall on any hypervisor. Then we have the cloud services platform. We have XRV for our service provider environments. We have Firepower, the Firepower next generation firewall, which is also available as a virtual appliance. We have the next generation IPS, which is also now available as a virtual appliance. And then we have the web security appliance, which is a web proxy. We have an email security appliance, which can also be deployed as a VNF, which is virtual network function. Lastly, we also have Cisco's AMP, which is advanced malware protection. It's available as a virtual cloud also. Now, all of these, which was earlier hardware specific, vendor specific, now can be deployed on another platform as a virtual appliance. And VNF makes it highly scalable for you to deploy your infrastructure. So what exactly are the advantages of virtual network function? Why would I want to deploy VNF? Why should I move away from a physical hardware appliance? Well, the advantages of VNF are similar to server virtualization and cloud computing. Basically, we would have a shorter time to market because without the hardware requirement, we can launch new network functions as a virtual machine or a container. If you remember in earlier times, imagine if I had a physical appliance. Let's say if I had to deploy a new ASA. Think about the time frame it needs for us to basically deploy that ASA. The first thing I have to do is order that ASA, and then it takes an X amount of time for it to get delivered. Then I have to unpack it, mount it somewhere, and then I have to configure it. But now with VNF, with virtual networking, I could basically deploy an ASA on demand. My time to market becomes extremely less because I can deploy that as soon as possible. I do not have to wait for a physical appliance anymore. The second advantage would be we could scale up or scale down. With physical appliances, I was limited to budget. I was limited to amount of physical devices I have or the time it takes for it to get delivered. With virtual appliances, I can scale up or scale down. I could deploy 10 ASAs at one time, or I could scale down by destroying the VNF or maybe shutting down the VNF. The third most biggest advantage would be power consumption, and also we require less space. Because imagine all the physical equipments that you have. You need a big data center. You need to have space. You need to have air conditioning for keeping all those devices cool. Now with you having virtual devices, you don't need that much space. You don't need a huge data center, but maybe a big UCS server. That's all you need. So it reduces your CapEx and also reduces your operational cost, which is your OpEx. So these are your basic advantages of basically running the devices as in a virtual environment rather than running it as a physical appliance. Now imagine if you have different vendors who have different VNFs. So let's say if you want to support VNFs from different vendors and you want all of them to interact with each other. Now that becomes a problem because you want a single framework or a standard where all of these different VNF software appliances are basically interacting with each other without them working on their specific hardware. So we basically want a standard hardware which supports multiple VNFs from different vendors. Now ETSI, which is European Telecommunications Standard Institute, created a framework so that your different VNFs can basically function all together on a standard hardware, basically giving you network function virtualization for multi-vendor VNFs. Many vendors offer VNFs and service providers choose the VNFs that they need. Now, if you want to run VNFs from different vendors on a single open platform, we basically need a standard that describes how to manage the router, monitor the router, and even configure your VNFs. So ETSI gives you a framework so that multi-vendor VNFs can all come on one single platform. The framework also describes how to manage and orchestrate VNFs. So let's look at this architecture and look at the components of this ETSI architectural framework. There are 4 components inside this framework. The first one is VNF. As we discussed earlier, VNF is just a virtual device which was originally a hardware appliance. So taking the software away from the hardware and deploying that on a standard hardware is what ETSI is all about. So the first component is virtual network function. The second component is Nfvi, which is network function virtualization infrastructure. The third one is MANO, which is network function virtualization management and orchestration. And the fourth component is operations and billing support system. So let's look at the overview of all these four components and how do they fit in with each other. So here is an high-level overview of what the ETSI framework talks about. So here, like I said, there are four components to this framework. Now, if you look at this diagram, which is basically a high-level overview of the architectural framework, here we have, like I said before, four components. We have the NFVI, which is Network Function Virtualization Infrastructure. This is right here. This is the first one. Then we have the VNFs, which basically resides on top of that. We have our operations and billing support system, and then we have our MANO, which is here. So what exactly is network function virtualization? Like I told you earlier, the softwares were basically running on a specific hardware, like a Cisco router. The iOS was running on a Cisco router, an appliance basically. But now we've decoupled the software and the hardware. And instead of you running the software on a specific hardware, we basically give you an open standard hardware to basically deploy our VNFs. So here, network function virtualization provides you with hardware compute, hardware storage, and hardware network. There's obviously virtualization inside that, which gives you a virtual compute, virtual storage, and virtual network. So think about the NFVI it's basically a hardware and a software combined together to create a platform where we can run VNFs. So it's basically like a server machine that I give you, and I run some kind of software on that server machine, and inside that software I would deploy my VNFs. So NFVI only gives you a platform where you can deploy your VNFs. VNFs basically reside on top of your NFVI. Now, if you look at this second component here, which we see, which is the VNFs, there's also something called as Element Manager, which you can see here. Element Manager is basically responsible for network management of one or more VNFs. And this Element Manager can also be a VNF. It can be a VM. Then we have the third one, which is the MANO, which is on the right side here. This consists of basically three parts, or three items as such. The first one is Network Function Orchestrator, which is your NFVO. The orchestrator launches, maintains, and scales the VNF. So let's say if you want to deploy 100 ASAs, you can deploy that with NFO, which is basically your orchestrator, which is used to scale or maintain your VNFs. This orchestrator also validates and authorizes resource requests from NFVI components. The second one is my VNF manager. This basically performs lifecycle management. For example, let's say if I want to launch my VNF, or maybe maintain my VNF, or maybe tear down my VNF, or let's say delete my VNF. All this can be done from the VNF manager. And the third one inside the MANO is my VIM, which is Virtualized Infrastructure Manager. VIM basically manages and controls the hardware and the virtualization resources in the NFVI. It collects performance metrics, fault information, and also performs lifecycle management for all NFVI resources. So looking back at this diagram, you would see that VIM is specifically used to manage the resources of NFVI. Your VNF is basically used to manage or deploy your VNFs. And orchestrator is used to scale your infrastructure. Now, VIM is also responsible for VNF service chaining. A service chaining could be, let's say, enabling multiple VNFs to talk to each other. For example, let's say if I have a CSR router here, which needs to communicate with maybe an ASA. So this is my CSR and this is my ASAV. So if they want to talk to each other, even that can be done with my Vim, which basically gives the virtual networking, which is here, which is used to allow multiple VNFs to communicate with each other. The fourth one is my operations and billing support system, which is OSS and BSS. Here, OSS is basically used for supporting management functions like network inventory or management or even configuration. Let's say if you want to deploy some configuration, you can do that from OSS, which is my operational support system. The next one is the billing support system, which is basically deals with customer management and also includes systems for taking orders or even payments. So this was the basic architecture, which was composed of 4 components. We had Nfvi, which was basically your hardware and software component coming together to give you an environment to basically deploy VNFs, which is virtual multi-vendor VNFs. The second was my VNF, which was a virtual appliance. The third one was your Mano, which basically again consisted of 3 things: NFVO, VNFM, which is your VNF manager, and Vim, which was virtualized infrastructure management. Remember, Vim was to control or manage your Nfvi, and VNFM was to manage your VNF, and basically to maybe delete VMs or delete VNFs or deploy them. That could be done with Mano all together, all these components coming together, and they work hand in hand. So what our focus is going to be, mainly it's going to be on network function virtualization. This is where we would focus on in this course. What exactly is Nfvi, which is network function virtualization? Like I said before, that Nfvi is basically a hardware and software coming together, the hardware being not a Cisco hardware or a Cisco router, but a separate hardware like maybe a UCS blade, a server, which basically comes together, which has a software on top of that, which allows you to deploy VNFs or install VNFs on top of that. These 2 things together, which is your hardware and the software, to basically provide you an environment where you can deploy VNFs, is called as Nfvi. Now you may think, why do I need to deploy an Nfvi? Why do I need to do this? Now think about the current network. Let's say if you had only physical appliances. What's the problem with this physical appliance? It's vendor specific. Different vendors may not interact with each other. And the problem is it lacks elasticity. It's extremely costly to deploy or manage, and longer innovation cycles. That's the biggest problem in today's environment. But with you going to the NFV infrastructure, you basically are giving an open standard infrastructure or a hardware where you can deploy multiple VNFs. This could probably be a Cisco device. This could be maybe a Juniper device, and maybe this could be like a Palo Alto. So now I can have multiple VNFs on a single hardware appliance, which is an open standard. Now Cisco has its own implementation of Nfvi. So you could basically do an open standard deployment, which could be as per the ETSI framework, or you could deploy based on Cisco's implementation of Nfvi. Now, when I say Cisco's implementation, that does not mean that it basically is away from ETSI. Cisco's framework is also based on ETSI. So the framework was still kept the same. The only difference is that the underlying infrastructure, which is for your Nfvi, is a Cisco appliance. So Cisco's Enterprise Network Function Virtualization software, which is called as Cisco Enterprise NFVIS, is a Linux-based infrastructure software designed to help service providers and enterprise customers to design, deploy, and manage network services. Cisco Enterprise NFVIS also helps dynamically deploy virtualized network functions such as a virtual router, firewall, WAN acceleration on a Cisco supported device. So Cisco's implementation is based on the same framework of ETSI. The only difference is that the underlying infrastructure for your NFVIS is going to be a Cisco device. So NFVI provides a virtual layer and a hardware environment in which VNFs can operate. In short, NFVI is all the hardware and the software we need to create a platform where we can run VNFs on. Many VNFs are available as virtual machines. So this is where we find our physical servers, storage, networking, and virtualization layer. For example, your hypervisor. So if you ever think about NFVI, think about your hardware, which could be your UCS blade. It could be your physical servers or your storage or your virtual networking. All that is done inside your hypervisor, which is all coming together, your hardware platform and your software platform coming together as NFVI. And that's where you will deploy your VNF. So let's look at the high-level architecture of Cisco's Enterprise NFVIS. So again, it's pretty similar to the earlier slide that we saw of ETSI framework, where again here we have your Mano, which is here, which again consists of all those three parameters, but all the three parameters used inside that, which was your NSO and your VNF manager and your Vim, all three of them would be Cisco specific devices, which would be used to manage all of this. Your NFVI would only be Cisco's implementation. Obviously, your storage and compute and network could also be an open standard infrastructure. So here is Cisco's NFVI deployment example. What products you would use when you deploy Cisco's NFVI solution. For the hardware, Cisco would recommend UCS blades, so UCS servers for the compute. For the storage, again, UCS storage servers, and for the network, it would be Nexus switches. Your virtual environment inside NFVI is given to you through Red Hat KVM, which is basically used to create a virtual environment. For example, your virtual networking or virtual storage or virtual compute. That is done with Red Hat KVM. For VNFs, we can obviously deploy Cisco VNFs, or it even supports third-party VNFs. So if I just use this component of Cisco's NFVI, I could deploy VNFs, which is Cisco, or I could even deploy non-Cisco VNFs on Cisco's hardware, which is basically your NFVI component. And as far as the Mano is concerned, for Cisco's implementation, Cisco uses for NFVO, which is for the orchestrator, Cisco uses NSO, and for VNF manager, Cisco uses the ESC, and for Vim, an example would be Cisco ACI. I hope this video was informative to you, and thank you for watching.